In your JProCode database, create this simple table that has the bonus ID, which is an integer, and the bonus amount, which is a money data type. Refresh your tables folder under JProCode. Notice that it's there. And let's look at the design view. These are two fixed length fields, so calculating the row consumption of every single row can be done before we even put data in it. Well, how much space does an integer take up? 4 bytes. How much space does a money take up? 8 bytes. Okay, let's calculate our per row consumption. With the table created, let's go ahead and put in a few records. Let's run this insert statement and then look at our table. All right. How much is row 1 going to take up? Well, here's a quick rundown. The header takes up 4 bytes. We have two fields of fixed length data, an int that takes up 4 bytes and a money that takes up 8 bytes. Does the fact that in my first row, the money having a null change the space consumption? No. Fixed length data always takes up the amount that the data type allocates regardless of what you put in it. Therefore, our fixed length data is 4 plus 8 or 12 bytes. Okay, we have one nullable field. Therefore, we have a 2-byte null block plus one more byte for the first 8 fields. Therefore, our null block is 3 bytes. How about our variable block? Do we have any variable length data? No. So we don't have a variable block, and we don't have any variable data. 0 on both of those. Looks like each row in this table is gonna take up 19 bytes. So how much would 1,000 rows take up? 19,000 bytes, which would fill up about 3 pages of data. Let's go check this assertion. First of all, we don't have a whole lot of data in here. We have 3 rows, with each row taking up 19 bytes, so right now we're taking up about 57 bytes. I'm pretty sure 57 bytes will fit inside of one 8,000 byte memory page, but there's this handy stored procedure called space used. So I want to execute the space used stored procedure and pass in the bonus table. Let's see what it says my consumption is. It says I'm taking up 8K of data. Well, that means I'm in the process of filling up my first page of data, and I could probably add a lot more records before this thing finally fills up. So here's what I'm going to do. I'm going to put in 997 more records, starting with record 4. So here's how this looks. What we're going to do is we're going to declare a variable called ID, which is an int, and set it to 4. As long as this is below 1,000, we're going to keep inserting these records. So let's go ahead and run this loop. Look at our bonus table, and notice we have 1,000 records of bonus ID. We haven't filled in the amount, and we figured that's going to take up 3 data pages. 19,000, it'll fill up an 8,000 data page, another 8,000 data page, and a little bit left over for the 3rd data page. Let's look at that. Sure enough, 24K of data is being used. Now, does this seem a little wasteful? If nulls are no data, how come every row is taking up 8 bytes in the money field? Just because it's a fixed length? Well, there's a new feature to SQL 2008 for fields that you expect to be predominantly null. Maybe every record's null. Maybe 95% of them are null. And you want to say, hey, don't allow the nulls to take up space, and we'll compensate for the non-nulls in the rare situation. Well, what we're going to do is we're going to delete this bonus table and recreate it using the sparse option. Here's what we do. This create table statement, we know we're going to have a bonus ID in every record, but the money we expect to almost never be populated. We're going to put the word sparse, S-P-A-R-S-E, in the create table statement. Let's run this. Since there are our first 3 records, just to make sure we've got everything we need. Okay, looks normal. Now let's insert 997 more records. Okay, do we have 1,000 records in there? Yes, we do. How much space is this 1,000 records taking up, knowing these nulls are not taking any space? Wow, it looks like we only filled 2 of the data pages. This helps save a significant amount of space in large tables. As cool as this sparse feature is in SQL 2008, you should be aware of 2 limitations. Number 1, if you do decide to populate the sparse field, then it's going to take up more space than a regular field that's populated. Now let's use an example. First, let's get rid of the bonus table. Recreate it. And now we're going to have a bonus of $1,000.99. How about that? And that'll be bonus 2. And that'll be bonus 3. And that will also be every other bonus. Now when we look at our table, we can see that our sparse nullable field is populated in every single record. What did that do to our space consumption? Wow, it went up significantly. So you should only use the sparse feature for fields you know will be sparsely populated. Another limitation is the fields that make great candidates for the sparse feature. Now, looking at the room chart table, it's pretty plain to see the most sparsely populated field is the room notes. We have yet to put any data in that. So, let's venture on down to that and go to the design. Make sure you've selected the room notes field, which is an n-text data type, and change the property of is sparse from no to yes. Okay, looks good. Save the table. And look at this. You cannot replace a sparse column in the room because it is an option or data type that is not valid. Here is one of the limitations, so let's change this back to no. You cannot use large object types with the sparse feature. You also cannot use CLR types like geography or geometry. But you can use numeric types and all of the character types like nvarchar, varchar, char, nchar, integer, decimal. So one of the limitations of the sparse feature is only certain data types will work with it. Lab 4.1, Skill Check 1. The company name field in the customer table is sparsely populated. Currently, the customer table is taking up 48 kilobytes. Change the company name field so that it's optimized for sparsely populated data. When you're done, check the design view of the customer table and confirm it looks like the figure you see here. That wraps up Lab 4.1, the sparse data option. Next up, Lab 4.2, custom data types.